In a world full of mystery, the Earth instrument reveals the world's secrets. The James Webb Space Telescope, JWST, known as Webb, is a pioneer in providing spectacular views of the stars, planets, galaxies and other wonders of the universe. As the successor to the Hubble Space Telescope, JWST has set new standards for scientific observation and dynamics. From one corner of the world to another, people share photos or use raw data to create amazing landscapes. Just 3 minutes ago, James Webb captured the most disturbing picture ever taken. It's been a year since the James Webb Space Telescope made its first landmark appearance, surprising astronomers around the world with its incredible information. However, the new discovery paints a stunning picture of a world unlike anything we've ever seen. Observations made by the James Webb Space Telescope show more progress than ever before. According to scientists, this successor to the Hubble Space Telescope has revealed new information about star formation, galaxy mergers, and the early universe. Just a month after the first images were released, the images are already showing the world in an unprecedented manner. Since then, the number of discoveries has skyrocketed, providing scientists with a vast treasure trove of data. The James Webb Space Telescope's images of the magnificent Tarantula Nebula, record-breaking cosmic dust clouds, stars near their explosive deaths, and other awe-inspiring celestial objects have been meticulously catalogued. This satellite observatory's cutting-edge technologies allow us to peer further into space than ever before, unveiling previously unknown details about the universe. Some of these observations commemorate the first year of the James Webb Space Telescope's operation. NASA released an image showing a small star-forming region in the Rho-Ophiuchi cloud complex, depicting jets shooting from baby stars as massive clouds of different colors influence molecular hydrogen, which forms the red clouds. The existence of circular disks around some stars suggests that planets may have formed in the past. It sounds sad, but according to NASA, this beautiful nursery is small and quiet compared to others. The living stars in this region are about the same size as our Sun or smaller, making it the closest star-forming region to Earth. This photo was taken by the probe's first camera, the Webb Space Telescope Near-Infrared Camera, NIRCam, which captures amazing images in 2 different regions at once. In addition, telescopes have increased their understanding of exoplanets, or planets orbiting stars other than our Sun. James Webb was very influential in the study of distant galaxies. In early 2023, the probe will discover its first planet, LHS 475b, which is 41 light-years away and about the diameter of Earth. According to NASA, the James Webb Space Telescope is the only operational telescope capable of analyzing the atmospheres of Earth-like planets on a large scale. The findings show how accurate the telescope is, pointing to solid exoplanets as a new frontier for astronomers. The James Webb Space Telescope also found evidence of ancient galaxies that should not exist. Swinburne University and its team of planetary scientists have discovered 6 ancient epic galaxies, known as world breakers, which will have a huge impact on our understanding of space. According to the results of experts, these giant galaxies may have appeared between 500 and 700 million years after the Big Bang. Recently, the telescope's infrared sensors have shown that we can look back 13.5 billion years, when the stars and galaxies were very stable. Scientists were surprised by the size of the cosmic debris, as galaxies in the early universe were 10 to 100 times smaller than today. These 6 bodies could have a mass of 1 billion times that of our Sun, and the total number of stars in these galaxies would be 100 billion times that of our Sun. The discovery of massive galaxies like the early universe will challenge our understanding of how galaxies form. Despite advances in technology, the existence of massive galaxies has eluded experts. In addition, the discovery of a planet considered too massive for its star has re-evaluated our general understanding of planetary formation and planetary system design. According to research, a planet several times larger than Earth has been discovered in the planetary system around the very cold star LHS 3154, a star smaller than our Sun. Before scientists discovered it, they didn't believe this phenomenon could happen. However, new evidence suggests that the largest planet in our solar system may orbit one of the world's smallest stars, a very cold dwarf. This finding defies our expectations. These stars may have formed in large clouds of gas and dust, and planets may have formed from the gas and dust left behind in the material disk around the newborn star. However, the planet-forming disk surrounding the low-mass star LHS 3154 does not have enough solid mass to form a planet, but it does exist, so we need to rethink our theories of stellar evolution. And the planets. A good analogy is equilibrium. The internal temperature of the star must be the same as the external heat source. When the temperature of the hot spring drops, you need to get closer. So are the planets. It must be hot enough to transport liquid water, and it must be close to the stars. For example, Dad is in the living room because of the heat and light of the sun. Different planets are either too far or too close to our sun for a moon to support life. Imagine a world with a very cold star. The same goes for planets orbiting a star with enough energy to support life. The size of the planet must also be adjusted to provide the optimal distance of energy and light to support life. Going back to the previous discussion, there are many theories as to why this planet formed so close to a dwarf star. According to a popular theory, the planet may have been larger in the beginning and lost a lot of mass over time. However, this theory is flawed because the planet has more air than solid matter. In this situation, it is considered that most of the mass of the world is ash, which is not consistent with this finding. Another explanation is that this giant world formed far away from a small star. If the planet could block enough light, it would probably be covered in ice. A planet can pull a star away, and a larger planet will move closer to a smaller star. Although both theories can explain the observed pairing between a star and a planet, scientists still do not fully understand this phenomenon. With advanced technology like JWST, scientists are exploring planetary systems in greater detail, and each new discovery pushes them forward. It goes deeper into what the world has looked like in the last 30 years. In recent months, the amount of data provided by the telescope has produced major scientific breakthroughs that have amazed astronomers and inspired future space exploration. With the James Webb Space Telescope now in operation for a year, one thing is clear: the universe is more complex than we previously thought, and there are many questions to be answered. The James Webb Space Telescope, launched by NASA in December 2021, represents a major leap forward in our quest to understand the universe. Dubbed the successor to the Hubble Space Telescope, JWST is a new technological instrument designed to capture images of celestial objects over a larger area than ever before. At the heart of JWST's capabilities is the large main mirror, 6.5 meters, 21.3 feet, in diameter, more than twice the size of the Hubble telescope. This allows JWST to collect and focus more light, allowing it to see fainter, more distant objects with greater clarity in detail. One of JWST's main instruments is the near-infrared camera, NIRCam, which is essential for observing the universe in the infrared spectrum. Infrared light is important for studying celestial bodies because it penetrates dust clouds in space that block visible light and reveal hidden stars, galaxies, and planetary systems. NIRCam operates at multiple infrared wavelengths simultaneously, providing astronomers with valuable information about the temperature, structure, and motion of distant celestial bodies. Another important instrument on JWST is the near-infrared spectrophotometer, NIRSpec, which breaks light from distant objects into its various colors and spectra. By analyzing these spectra, astronomers can determine the chemical composition, temperature, and motion of distant stars, galaxies, and exoplanets. This ability to understand the true complexity of the universe is invaluable and will continue to drive scientific discovery for years to come.